We have finished now with the linear functions, and that's anything of the form y equals mx plus b. And now we move into the quadratic function. College algebra is the study of functions. When we leave chapter 2 and go into chapter 3, we'll be studying the polynomial and the rational functions. And then chapter 4, we study the exponential and logarithmic functions. College algebra is the study of functions. Okay? And so our next one is going to be degree 2. So we finished with degree 1. We're now on the degree 2. And this is another one you're familiar with. A quadratic function is of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. A can't be 0. A can't be 0 because if a is 0, then it's linear. And its domain is the set of all real numbers. That has to be the case. No radical, no denominator, all real numbers. So polynomials in general, and the quadratic is a polynomial. And we know something about the quadratic. If I look at a picture of a quadratic, it is either a U-shaped graph that opens up, because they all look the same. It has this thing at the bottom, and this thing at the bottom is called the vertex. And I'm going to label it like I do in intermediate, x sub v, y sub v. That's the coordinate point of the vertex. We know that the domain is all real numbers. And if you look at the range, the way the range is going to work, it's going to start at the y coordinate of the vertex and go on forever. So it's the y coordinate of the vertex to infinity. So I'm just going to put it in interval notation. Or the other choice we have is a U-shaped graph that opens down. Again, his domain is all real numbers. He has this thing which is called the vertex, which again is x sub v, y sub v. And if you notice, the range stops at the y coordinate of vertex, but it comes in from minus infinity and stops at the y coordinate vertex. Intervals are always in number line order. So it's minus infinity, y coordinate of the vertex. And quadratics are really nice because they all, you can predict what they're going to look like. You can predict what they're going to look like. Now, we've seen this form of the quadratic before. It's standard form. And this is really transformation form. And I've put it that way. And you notice that I have HK. And if you look at this as being a transformation, I notice that this is where you're going to find left, right. This is where you're going to find up, down. And here, it's a twofer. It is either, because it's on the outside, a vertical stretch or vertical shrink. And the second thing is it could be a reflect. The x-axis if A is negative. So it's in transformation format. That's what standard form is. Now, if I look at standard form, the vertex is h comma k. H and K, left, right, up, down. Stretches and shrinks don't affect the vertex. Because remember, the vertex starts out at 0, 0. So if you stretch or you shrink in any fashion, that thing is still tacked down at 0, 0. So the vertex doesn't change. However, what changes the vertex is left-right movement and up-down movement. That'll move the x values or the y values. Okay? So the vertex is HK. Now, for the most part, you can put things into standard form if you would like, and it's done by completing the square, which is a really not fun thing to have to do. Once you have calculus, it's no longer necessary. Calculus eliminates that necessity to complete the square. However, we can work around it. Don't have to complete the square to do it. You can actually work around it.